This is another slow motion video to go through slowly through a problem, one problem. This problem is from page 5. It's 2b. And in this problem, you're going to do it a little bit differently than usual because normally when you do a binomial expansion, you can use Pascal's triangle and write out every single term because they want every single term. But sometimes what they're going to do is they'll give you a huge binomial expansion, like look at this one, n equals 17, or the power is 17. That would be an 18-term polynomial, and they don't want you to write every single term on the exam because that would take a really long time, and all it would prove is you know binomial expansion, and they don't want you to spend that much time on it. They want you to get the problem done in 5 minutes and move on to another topic. So, but they do want to kind of know if you know how to expand something with 17 or 18 terms. And so what they're going to do is they're going to say, give me one term. Give me, for example, the 10th term of this binomial. And if they say that, you're not going to have to expand the whole thing out and write out 18 terms. What you're going to do is you're going to use the formula sheet. On the formula sheet, you're going to see this expression written for binomial theorem. You can see that on the left side it has the standard form for the binomial to the power, and on the right side it shows a few of the terms written out. And the terms that are written out is the first term, the second term, and the last term here. And what about this term here? Do you see how there's like a dot 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 here and there's a dot 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 there? Okay, so those two dot dot dots are kind of setting this term off by itself. The dot 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 means, hey, in between here and here, there's other terms, but we're not worried about those. Just look at this term here. This term is called the general term, and I wrote it out here a little bit bigger. The general term is the one that really counts. You want to know, what does every term look like, okay? And that's what they mean by general term. General term means it's not the first term, it's not the second term, it could be any term within the sequence. Okay, so how do you identify a term within the sequence? Usually we say the first term, the second term, the third term, right? So let's write that out. First term, second term, third term, okay, all the way to the last term, which would actually be the n plus 1th term. What do I mean by that? Do you remember how the number of terms in a binomial expansion is kind of related to the power you see here, but it's not exactly the power? Because, like, remember, if you have a quadratic and you have a 2 here, remember there's 3 terms in it? So there's always one more term than the power here. So that's why I say it's the n plus 1th term, because if your n value was 17, this would be the 18th term. Okay? So when you write out your binomial expansion, the last term is going to be n plus 1th term. Okay. Now what does this r mean? The r value that's here, and the r value that's here, and the r value that's here. The r value kind of refers to what position the term has in the equation, but it's a little bit different than 1, 2, 3, and n plus 1. It's actually one less. So the first term, the r value is 0. The second term, the r value is 1. The third term, the r value is 2. Okay, do you see how it's always one less than the ordinal number of the term? So n plus 1th term, the r value would just be n, right? Okay, so that's what the r means. So if you know which term you want, you can kind of figure out what the r value is, and if you don't remember exactly how to do it, I would write this list out. 1, 2, 3, blah, 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 to the n plus 1, and underneath that you could write r equals 0, r equals 1, all the way to r equals n, because this is not in the formula sheet, but you could figure it out, right? Okay, and the n value that's written here, of course, is the power, so this would be the 17. What about the a and the b? The a would be the first term in the binomial, and b would be the second term in the binomial. Now, what if you have a negative sign in front of them? Remember to keep that negative sign together with the term itself, okay? So in this question here, they're asking us for the 10th term of x minus 2 over x to the 17th. You could say that, okay, a value is going to be x. B value is going to be negative 2 over x, right? Because it includes everything including the minus sign. And the n value is going to be 17. Okay, what's the R value going to be? Okay, like we just talked, if it's the 10th term, then that means it would be 1 less than 10, so R value would be 9. Now that you have all these numbers, now you just need to fill everything in to the general term. So the general term formula is n chooses R, a to the n minus r, b to the r. Okay, and n chooses r would be 17 chooses 9. A to the n minus r would be x, and put everything in parentheses here. It's just like when we had triangle and circle for a and b. Keep parentheses around whatever you put in for a and b. N minus r would be 17 minus 9. B would be negative 2 over x. Make sure you put parentheses around it. To the r power, which is to the 9th. Okay, now we just need to simplify. And maybe we need to use our calculator to do 17 chooses 9, right? Remember, 17 chooses 9 could be done manually, and the way you do it manually is you say, okay, it would be 17 factorial divided by 9 factorial divided by 17 minus 9 factorial, okay, which would be 8 factorial, okay? And this problem would probably be on the calculated part of the exam, but you could do this by hand if you needed to, because you just need to write out all the numbers and do a bunch of canceling, okay? So let's do this on the calculator real quick. I got the calculator out. I type in 17 first, then I go to the math menu and I go to probability, because that's where you find n chooses r function. I type n chooses r, and then I type 9, and the answer is, wow, 24,310. Maybe we wouldn't have been able to do that without the calculator, okay? So we're going to come back here to the paper, and we are going to write that 17 chooses 9 is 24,310, okay? Then x to the 17 minus 9th is x to the 8th, and negative 2 over x to the 9th is just negative 2x over negative 2 over x to the 9th. And now remember, we're going to take the 9 and we're going to distribute it to both the 2 and the x and the negative sign. So when you do negative sign to the 9th, do you end up with a negative or a positive? Well, if it's an odd number, if you multiply a negative times itself an odd number of times, you'll end up with negative, right? So we'll end up with a negative here times 4, 3, 1, 0, x to the 8th. I don't need the parentheses anymore because there's only one thing in the parentheses. I've already taken care of the negative. Now I'm going to distribute the 9th power to the 2 and to the x. Okay? And now I've got, now I'm going to simplify. Negative 24,310. X to the 8th divided by x to the 9th is x in the denominator, right? And 2 to the 9th on top is just some huge number. I'm going to use the calculator to do that also, and then I'm going to multiply it times 24,310. Hold on a second. Let me put the calculator back here on the screen. So I'm going to do 24,310 times 2 to the 9th. Wow. 12446,720. So the answer is going to be negative 12446,720. Wow, 12 million divided by x.